the parent function. So we've already said a couple times, a rational function, what is it? It's the ratio of two polynomial functions. And they're not zero, and they don't have any common factors, so you can't cancel them out. So it says, consider this function y equals 1 over x. This is the parent function. Without graphing it, how could you determine its domain? What would make the denominator 0? When x is 0, right? So our domain should be that x can never be 0, because you can never have the denominator be 0. And then it just says, let's graph it by using a table of values. So if I plug in these values for x, what are my outputs? So if I plug -2 into the denominator, I get -1/2. If I plug -1 into the denominator, I get -1. What happens if I plug -1/2 into the denominator of a fraction? What's 1 divided by -1/2? Does anyone know? When you divide by a fraction, don't be shy, flip the second and multiply. So it's really like multiplying by -2. So if you divide $1 into 50-cent pieces, you actually have two 50-cent pieces. So I'm at -2. What happens if I divide by -1/4? 1 divided by -1/4 is -4. So let's graph these 4 points. This is half of our graph. So -2, -1/2, -1, -1, -1/2, -2, and -1/4, -4. So it's an elbow that gets really close to the x and y axis. And then what did we say happens at 0? If we plug 0 into this function, what happens? It'd be undefined, right? So there's actually an asymptote, which is a dotted vertical line at x equals 0. There's an asymptote. So then let's plug in these 4 values into the denominator. So if I take 1 and divide by +1/4, now I'm going to get +4, right? Take the reciprocal of 1/4. What if I plug in 1/2? I'm going to get +2. 1 divided by 1 is 1. 1 divided by 2 would give me 1/2. So when I graph these 4 coordinates, it gives me the other side of this parent function. So 1, 2, 3, so I'm at 4, and then I'm at 2, 1. So it's this other elbow that kind of gets closer to the x and y axis. That is the parent function of a rational function. And we're not going to graph all of those points, so just kind of knowing that this is at 1, 1, bends, and this is at -1, -1, and it bends. Those are kind of the 2 key points of the graph. And it says, what's the end behavior? So what's happening as x goes to infinity and -infinity? As x approaches infinity, f of x gets closer to 0. Oops, and then as x gets closer to -infinity, f of x gets closer to 0. So our end behavior is, as x goes towards positive or negative infinity on the graph, the function itself is approaching that horizontal asymptote at 0. What's the range of the function? So what are all the allowable y values? Can it be any y value that I want? What do you think? Is there any y value that it can't be? There is a y value that it can't be. Yes, it can never be 0. So if y can never be 0, that is going to be a... Okay. Y can't be 0. There's actually a horizontal asymptote at 0 on the parent function. So I know it's hard to see, but it has 2 asymptotes. The 2 axes are actually asymptotes that the graph approaches but never touches. And that's because the range and the domain are basically x can never be 0 because I can never have 0 in the denominator. Y can never be 0 because if the numerator is always 1, you can never get to 0. And it says rational functions are one type of function that has asymptotes. An asymptote is a line that a curve approaches as it heads towards infinity. What asymptotes do you see in this graph, and how do they relate to the domain and range? So basically, x equals 0 and y equals 0 are our 2 asymptote lines. And we're going to spend tomorrow finding some asymptotes, or finding intercepts, I guess. So on the back here, if our parent function has those asymptotes, then these are just transformation rules, moving the function left, right, or up, down. So it says, recall the transformations you already know. For each function, identify the transformation rule and sketch the graph. So you're going to use your 2 asymptotes. So if your original asymptotes are at 0 and 0, if it moves left or right, you're just going to move this pink line left or right. And if it moves up or down, you're just going to move this pink line up or down. And then you're just going to use these 2 points, 1, 1, and -1, -1, and draw your elbow. So wherever you draw your little cross, like if this is your axis and now your cross is like over here, right? Then those are your 2 key points that you'll just have your elbows going in those 2 directions. So let's do the first one together and then maybe you try the other ones. What direction is this going to go? So if I've gone x minus 1, where am I going? Is that left, right, or up, down, do you think? X minus 1. Right 1. So we're still practicing transformation rules from Unit 1. What is this plus 2 going to do to the graph? Up 2. So I'm just going to change where I write my asymptotes. Up 2, my new asymptote is going to be at positive 2. And right 1, my new asymptote is going to be at positive 1. And then I'm just going to draw my 1 key point, kind of 1, 1, and -1, -1 away from those asymptote lines, and just kind of show that there's an elbow and that there's an elbow. We're not going to get really fancy with a lot of key points. Just knowing which region you're in, and then it bends towards the asymptotes is a good start. And it says, give the vertical asymptotes and the domain and the range. So this is at y equals 2, x equals 1. What would be my domain? X cannot equal 1. My range is that y cannot equal 2. So that you record your asymptotes as equations and you record your domain and range as x cannot equal and y cannot equal. So I'd like you to take a few minutes and just think about the transformation rules on B and C and see if you can figure out how to graph them. Maybe do it in pencil, but see if you can imitate that same process for the next 2 things. Left 3, down 1. See how it's still practicing your same transformation rules? 1, 2, 3. There's my left 3, down 1. And then put it kind of 1 unit away in either direction, and there's your 2 elbows. So this is at x equals -3, it's a vertical line, and y equals -1, it's a horizontal line to record your asymptotes, and then your domain is recorded as x cannot equal -3, and your range is y cannot equal -1. So if you're writing the equation, it's an equal sign. If you're writing domain and range, it's a does not equal sign. All right, and then the last one has an additional transformation. It has a reflection going on. Okay. What does this do, and this do? So if it's a negative sign in front of the function, it's a flip upside down, right? Or we say that it's a flip over the, what's that, x-axis? And then this should have gone left 1, and this should have gone down 3. So knowing like x is always left or right, outside the function is always up or down, all of those transformation rules stay the same. So let's see, I'm going left 1, and I'm going down 3, 1, 2, 3. And then basically, instead of putting my dots here and here, I'm just going to flip my 2 little dots over, right? So I'm going to put one of the dots here and one of the dots there. So my elbows basically just flip upside down over the asymptote. So that's why over here, I just wrote that it flips upside down. It's technically not flipping over the x-axis because I've shifted the x-axis using that asymptote. So the flips can be a little bit tricky, but I think of the asymptote as my original kind of xy axis. And so I flipped over my kind of new imaginary x-axis. So x is at -1, y is at -3 for my asymptotes. My domain is x cannot equal -1, and my range is y cannot equal -3.